Hey, hello friends, and welcome to Retro Portal Studio, and in this video we're going to take an in-depth look at top widgets for UI design in Flutter, which every Flutter developer must know. The ranking of widgets in this video is just for demonstration and does not hold any special meaning. This is going to be a long video and you can find the timestamps for all the sections in description below. Some of the widgets in this video might seem simple, but I strongly suggest you to watch the detailed explanation because for each widget we're going to look at all the essential properties and you might find some new use cases for the same widgets. So without further ado, let's get started. Okay, so let's say we have a simple app in which we have only one text view on the screen and it is sticking to the top left corner of the screen. So what a center widget lets us do is, well, it helps us center the widget. But whose center? So to use the center widget in Android Studio, what I can do is I can click on this text here and click on Alt Enter, and it will prompt me with the options, and I can click on Wrap with Widget. And what I will do is I will wrap the text with a center widget. And if I click on Save Now, and it will hot reload the app into the emulator, and what you can see is the text is in the center of the screen. So basically what a center widget does is it takes the width and height of the parent and it centers the set widget, that is the child of the center widget, into the center of its parent. So by default the center is having the width and height of its parent. So what if you want to change that? So other than this child property, center is also having two other properties that are called height vector and width vector. So let's take a look at height vector first. So let's say I move the child down and add a height vector here. And what a height vector will do, it will take the height of this text view and it will multiply this height by the height vector and it will assign that height to the center. So right now in the emulator we have a text view in the center here. And if I add a height vector of 2 and if I save the app again, so now what you can see is that the text view is no longer in the center of the whole scaffold. So why is that? So basically what's happening is that the center is taking the height of the text view and multiplying that by the height vector and then assigning the height to the center itself. So right now the center is taking this much height and is centering the text view inside of that. And you can also see that the width of the center is the exact same width of the scaffold. This is because we're not using the width vector right now. So let's take a look at it. So if I go down here and add a width vector also and give it a value of 2 and then save it. So now you can see that the width of the center is no longer the width of the scaffold. It is twice the width of the text view, that is the child of center. So basically what center is doing right now, it's taking the width and height of the text view and then multiplying that width and height by the width and height vector, that is 2 at this point. So the width of the center is going to be twice the width of text view and the height of center is going to be twice the height of text view, and it's centering the text view inside of it. So you can say that the child is the most important property of the center, and if you want to adjust the width and height of the center, you can use the properties called width vector and height vector. So a container is one of the most used Flutter widgets, and it is for a reason. When you add a child to a container, what you can do is add a background color, shadow, margin, alignment, and you can also transform the widget by adding rotation, scale, and much more. So let's say we have a simple app here in which we have only one text on the screen, and that is at the center of the app using this center widget. So what we want to do is we want to add a background color to this text. So that can be done using a container. So basically what we have to do is we have to contain the text inside a container. So for that, what I can do is I can just click on this text and add Alt Enter on the Android Studio and wrap it with container. So what we want to do is we want to add a color property to the container. So in this case, I'm just going to use colors.blue. So in this case, what I also need to do is add a color to the text so it's visible in the container. So I'll just go to the text style and add a color. So if I save the app and see the emulator, you can see that the container is containing the text and the color of the container is blue, that is as the background of the text. But at this point you can notice that the text is touching the borders of the container. So what we want to do is we want to add a bit of space between the text that is the actual contents of the container and the vaults of the container. So for that, what we can do is I can just go to the container here, and other than the color, I can add a property called padding. And in the padding, I can add a new property that is called edge insets. And using the constructor all, I can just add a value of 8.0. So basically, using this property, I'm adding 8 points of padding to each side of the container. So if I save the app and go to the emulator, you can see that the container has applied 8 points of padding to the content, that is the text. So other than the color and padding, when I click on control space, you can see there are a number of other properties also. So the next property that we're going to take a look at is this constraints. So what constraints basically does is it helps you in giving minimum and maximum dimensions to your container. Let's say I want the container to take as much as possible width and height. So for that, what I can do is I can just use box constraints dot expand. So if I use this property and save the app, so you can see that the container takes all the available width and height available to it by its parent, that is in this case its center. So if I want to give my own box constraints to the container, what I can simply do is use a separate constructor of box constraints. So for that, what we can do is use box constraints and use this constructor here. And if I click on this, it wants me to give it 4 properties, that is maximum height and maximum width, and minimum height and minimum width. So from here, what I can do is I can assign a minimum width to the container. So in this case, I'll just assign a minimum width of 100. So if I save the app and run the emulator, you can see that there is absolutely no change in the container because it was already taking a minimum width of 100. So the problem will come if I just add a maximum width that is of 150, because the container is clearly taking more than 150 pixels. So if I save the app again and go to the emulator, you can see that the text wraps to the second line because the container maxes out at 150 pixels, but the text needs more space than that. So it basically wraps down to the bottom, and because we don't have any maximum height property, there's no problem in that. So basically, as the name suggests, constraints help you provide minimum and maximum dimensions for your containers. So let's say we keep the app at the box constraints of expand. So in this case, the container is going to take the full width and full height. So what we want to do now is we want to align the text in the center of the container. So that brings us to the next property of the container, that is the alignment. So by using the alignment property, we can align the contents of the container. So in this case, if I just write alignment dot center, you can see that the text appears in the center of the container. And you can also change the alignment to center left. And if I save the app, you can see that the text is aligned to the center left of the container. And you can provide all sorts of alignments that are given to here in the form of static constants. So I'll just keep the alignment at the center for now. So other than the alignment, we have a basic property of width and height. So as the name suggests, I can give a particular width to the container. So I can just write 200 here, and we can also add a height property that also says 200. But if I save the app and go to the emulator, you can see that there is absolutely no change. Because in this case, we're applying constraints and we're using the constraints of expand. So a container is taking the full width and height that is available to it. So in most scenarios, what you do is you either add the constraints or add the width and height. So if I remove the constraints for now, I'll just comment it. And if I save the app and go to the emulator, you can see that the container takes 200 width and height and is a complete square. So I'll just remove the width and height from here, and we move on to the next property that is called transform. So by using the transform property, we can change the scale, rotation, and all sorts of dimensional properties of the container. So in this case, I'll just show you the example of changing the rotation of the container. So in this case, what we have to do, we have to use matrix for dot rotation. And for rotation, I'm just going to use the z-axis. So for that, I'm just using the function called rotation z. And we have to pass radians. These are not degrees, these are radians. And if you don't know what radians are, you can just take a quick look by a search on Google. So in this case, I'll just provide a value of 0.5, which is approximately equivalent to 30 degrees. So if I save the app right now and I go to the emulator, you can see that the container is rotated by 30 degrees right here. So in this case, it's quite hard for me to see the container. So what I will do is I'll just remove the constraints and add a width of 200 and a height of 200 also. and I save the app and go to the emulator, you can see that the container is rotated by 30 degrees. So there are all sorts of other properties in the transform. So we'll basically be taking a look at transform in another individual video because it itself is a much more detailed concept. So I'll just remove the transform property from here right now. So the other property that we want to take a look at is decoration. So by using the decoration, you can change a number of properties of the container like the shadow, the shape, the borders, and the box shadow. So for adding decoration, what you have to do is you have to use box decoration. And in the box decoration, you have a number of properties like color, border, border radius, and so on. So in this video, we'll be taking a look at the most used properties for the box decoration. So the first one is the color. So for the decoration, you have to keep one thing in mind, that you can't use the separate color property if you want to use the decoration property of the container. So we'll have to supply the color in the decoration. So I'll just give the color of color blue, and if I save the app and go to the emulator, you can see that there are absolutely no changes in the app. So other than the color, we're going to take a look at border. So for providing value to the border, you can use a simple constructor of the border class. So in this case, you have to provide separate values to the top, right, bottom, and left. And instead of this, what you can do is you can also use border.all if you want to provide same type of border to all the sides of the container. So in this case, what I will do is I'll just use border.all and provide it with a color that is going to be colors.black. And I'll also give it a width. And the width is going to be of 2.0 in this case. And other than the width, I'll give it a style. And the style is going to be border style.solid. So if I save the app, you can see that the container is having a nice border around it. So you can also change the radius of this border by using the border radius property. So what this border radius requires is an instance of border radius, and I'm going to apply the radius to all sides. And in this case, you can provide a radius.circular, and the circular radius can be of 20.0. And if I save the app, you can see that we have provided 20-point radius to each corner of the container. So other than the border radius property, let's take a look at box shadow. So with the help of box shadow property, you can give multiple shadows to the container because the box shadow property takes a list of box shadows. So in this case, I'm just going to add one child to this list. So in this case, I'll just add box shadow, and the shadow is going to require color, spread radius, border radius, and offset. So for the color, I'll add colors.gray, and for the blur radius, I'll add it approximately to 4.0. And for the spread, I'll just keep it minimum at 1.0 or 2.0, let's say. And we're not going to give any offset right now. So I'll just save the app and watch the emulator, and you can see that there is a bit of shadow to the container. So for making it more visible, what I'll do is I'll just remove the border property from here, and I'll change the color of box shadow to red so that you can see the shadow clearly. So I'll just save the app and go to the emulator, and you can see that we have added a bit of shadow to the container. So other than the box shadow, we also have another property that is called gradient. So what you can do with the gradient is you can add a linear gradient or any other type of gradient to this property. So I'll just be using a linear gradient. So for using the gradient, we don't need to use the color property right here. So I'll just remove the color property, and I go down here to the linear gradient. And this requires a list of colors that the gradient need to move in between. So for the linear gradient, what I'll do is I'll just pass the list of colors. So in this case, I'll just use colors.blue. And for the second color, I'll use colors.light blue. And so basically, we'll be getting a gradient between the blue and the light blue. So this linear gradient also requires a starting and an ending point. So for starting, we'll have to add this begin property. So in this case, we'll add an alignment and add the alignment of alignment.center left, because we want to start the linear gradients from the center left position, and we want to end it on the alignment of center right. And if I save the app right now and go to the emulator, the change in the color is quite light. So I'll just change the color from light blue to white. And I'll save the app and run the emulator again. And you can see that the gradient is starting from the blue color and going to the white color from center left to center right. So other than all these properties, we also have another property that is called shape. So for using the shape, I'll just have to remove the border radius property from here. With the help of shape, what you can do is you can add a predefined shape to the container, or you can create your own shape. So in this case, I'm just going to use a predefined shape that is going to be boxShape.circle. And I'm just going to save this and go to the emulator, and you can see that the container has changed its shape from rectangle to circle. So instead of adding the border radius, you can simply use the shape property right here. So these are all the properties that are associated with the container and the box decoration that is used as a value to the decoration property of the container. So row and column are frequently used to arrange widgets in horizontal and vertical fashion respectively. Both these widgets have a children property which takes a list of widgets. We will be taking an example of row here, and the knowledge is transferable to column widget. Right now I have a center widget in which I have a simple text. So let us say instead of this we want to have 3 buttons horizontally, that is along the x-axis. So we have to use a row widget for it. To use it, we simply replace this text with a row, and in this row we have to add a children property. Now this children property requires a list of widgets in which we have to add multiple widgets. So in this case I'll add 3 simple buttons, that is button 1, button 2 and button 3. So when I hot reload the app, you can see that there are 3 buttons arranged horizontally in the center. So what I'm going to do right now is I'm going to wrap the row in a container. So I'll just wrap the row in a container, and I'll give the container a color of colors.red. The reason for adding a container to the parent of the row is just to make you see that the row is taking full width of the screen, that is the available space. So what if we want to change that? For this, what we can do is add a simple property to the row, that is main axis size. And for the row, the main axis is always going to be the x-axis. And by adding this main axis size, what we can simply do is we can call main axis size.min, and if I save the app, you can see that the row is now taking only the space that is required by its children. And if we set this main axis size to max and I save it, you can see that the row is now taking the full width of the screen, and the main axis size.max is the default value for the main axis size. So let's keep this main axis size to max so that the row can take the entire width of the container. So what we need to do now is we need to align the children along the main axis, that is the x-axis for the row. So for that, what we can do is we can simply use main axis alignment, and by default the main axis alignment is set to start. And if we set the main axis alignment to center and save it, you can see that all the children move to the center of the row. And if I change this to end and save it, children move to the end of the row. And other than the start, center and end, we can also set space between. And by using this property, all the children will have equal space in between them. And there is another property that is called space around. And what this will do is that each of the child is having a space around it. So you can see that by using different values for the main axis alignment, you can align the children of the row along the axes in multiple ways. So at this point you can see that the height of the row is only the height that is required by its children. So just to give the row some extra height, what I need to do is I need to add the height to the container, and I'll just keep the height to 200. So right now, even if it's not visible, the row is taking the entire height of the container. So just to prove that, I can use another property that is called cross-axis alignment. And the cross-axis alignment in case of row refers to the y-axis. So by default, the cross-axis alignment for the row is at the center. And if I change the cross-axis alignment to start, and as soon as I save the app, you can see that the content of the row moves to the top. That is the cross-axis alignment.start. And if I change the cross-axis alignment to end, and I save it, the children of the row move to the very end of the container. And if we change it back to the center, all the children move to the center of the container. At this point, we can have another question that when we set the cross-axis alignment to start and save the app, why did the views move towards the top of the container? And the answer is quite simple, that by default, the vertical direction of the row is from top to bottom. And there is another property to alter this behavior, that is the vertical direction itself. And by adding the vertical direction to the row, we can set this vertical direction to up, and by setting this vertical direction to up, we're saying the row to change its vertical direction from bottom to top. And now if I save the app, all the views move downwards. So when I set the vertical direction to up, the start now moves to the bottom because the row is now pointing from bottom to top. And when we set the vertical direction to down and save the app, the cross-axis alignment start makes the views move to the top because now the row is pointing from top to bottom. So in the same way, we can also change the direction of views from left to right. And for that, we have to use a simple property called text direction. And by default, the direction of views in horizontal axis for a row is from left to right. So in this case, if I change the text direction from right to left, that is using RTL, and save the app, you can see that the button 3 comes first, then the second, and then the first. And if I change it back to LTR, that means left to right, the button 1 comes first, 2 comes second, and 3 comes third, in the same order that we're giving it to the children property. So basically, the default vertical direction of row is from top to bottom. So when we set the cross-axis alignment to start, it moves the views to top, and if we change the vertical direction to up, the row will now point to bottom to top, and the cross-axis alignment of start will move the views to the bottom. So these are the properties that you will require most when using the row widget. So the properties of the column are similar to that of the row, and the knowledge is transferable. So if I change the row to a column and save the app, you can see that the buttons get transferred to a vertical fashion. And to make it a bit more appealing, I can add a simple width to the container. And let's just make it 400 and save the app. And right now, the cross-axis becomes the x-axis and the main axis becomes the y-axis because the column aligns the children from top to bottom. So the main axis is the y-axis and the cross-axis is the x-axis. So right now we have the main axis size of max. So the column is taking the full height of the container. We have the main axis alignment to space around. So each child widget is having a space around them. We also have a cross-axis alignment to start, and the cross-axis in case of column is the x-axis, so all the views shift to the left-hand side because by default the container is moving from left to right because we have the text direction of left to right. So you have to keep only one thing in mind, that the vertical direction deals with the y-axis and the text direction deals with the x-axis. And how the vertical direction and text direction affect the main axis and the cross-axis depends upon the view. That is, in case of the column, the main axis is the y-axis, and in case of the row, the main axis is the x-axis. And just by experimenting with these views, you can understand these properties in a much better way because rows and columns are one of the most frequently used widgets in Flutter development. We have learned that by using row and column, we can arrange widgets in horizontal and vertical fashion. But there is a limit on what we can achieve using these widgets. So let's take an example. In this app, we have 3 buttons and they're being displayed in a horizontal alignment. Now, if I try to add 2 more buttons to it and save the app, the layout breaks and we have this yellow barrier that tells us that there is no more space to display all the child widgets. So in such cases where we do not have control over the number of widgets which we have to the row or column, and they can easily exceed the boundaries of the device, we can use the wrap widget. So if I replace the row with a wrap widget for now and save the app, you can see that the remaining views which earlier were not able to fit in the given device width move down to the next line. So by using the wrap widget, we can add as much views as we want as children, and they will wrap on the screen if the area is not enough for them to display. Good thing with the wrap is that we can use the wrap widget with both horizontal and vertical direction. Using the direction property of the wrap, we can change the direction of wrap widget. By default, the direction property of the wrap is set to axis.horizontal. And here, if I simply change the direction of axis to axis.vertical and save the app, you can see that the wrap now behaves as a column and all the child widgets are now aligned in a vertical fashion. So we can use the wrap widget both as a row and a column by simply changing the direction property of the wrap and changing it to axis.horizontal or axis.vertical. And even if I set the axis to vertical and I increase the number of widgets and save the app, you can see that the widgets now shift to a second column when the first column is filled to the bottom of the device. Now you see the true flexibility of Wrap Widget. Let's get back to the basic example and take a look at some other properties. So right now, even if not visible, Wrap Widget is only taking the space that is required by its child widgets. So to prove this, what I can do is I can make the Wrap Widget a child of a container and then add a width and height to the container. So I'll make the width a nice 400 and I'll give the container a height of 200. And I'll also give the container a color of colors.red so that the container boundaries are visible to you. And I'll save the app, and you can see that the wrap is taking the space of the container now. And suddenly, all the views move to the top left corner of the container. Now, to change the alignment of all the child widgets of the wrap, what we can simply do is change the value of the alignment property. And we can set the alignment property to wrap alignment.center, and if I save the app, all the child widgets of the wrap move towards the center, and the wrap itself is taking the full width of the container. So by simply changing the wrap alignment to end, I can align all the child widgets to the ends of the container, that is towards the ends of the wrap widget on the horizontal axis. And in the same way, I can change the wrap alignment to space around or space between. And if I change the wrap alignment to space around and save the app, you can see that each of the child widgets is having a space on its left and right hand side. So the alignment property of the wrap widget is a basic equivalent of the main axis alignment of the row and the column widget. And for the cross-axis alignment, in case of wrap, we have a run alignment. Yes, this is a strange name, but basically the run is the direction or axis in which the wrap will occur. So basically, if I add two more child widgets to the row, and now if I change the run alignment to wrap alignment.center and I save the app, you can see that all the widgets move towards the center of the container because the wrap widget itself is taking the full height of the container. So basically, the run alignment in wrap widget is the equivalent of the cross-axis alignment in the row and column widget. And you can set the same properties to the wrap alignment and change it to space around. We have multiple rows because of the wrap, and each row is having equal space around it. And if I change the space around to start and save the app, all the views move towards the top of the container, and if I change it to end and save the app, all the views move towards the end of the container. And I can change this behavior by simply adding another property that is called vertical direction. So by default, the wrap widget is pointing from top to bottom. So when I change the run alignment to end, all the widgets move towards the end of the wrap widget. And if I change the vertical direction to vertical direction.up, then the wrap will be pointing from bottom to top. So basically, the start will now be the bottom. And if I save the app, you can see that all the views moves towards the end, that is now the top of the wrap widget. So I've explained much about the vertical direction property in my last video that was about rows and columns. And I'll leave the link for that video in the description below. So feel free to check it out. So the next property that we can discuss after that is the spacing. So spacing deals with the main axis of your widget, that in this case is the horizontal axis. So if you're laying out the widgets in x-axis, that is by using the axis.horizontal, then the spacing will add a margin to the left and right hand side of each of the child widget. So if I add a spacing of 10 and save the app, then you can see a slight change in the spacing between each of the widgets. And if I increase this to 20 and save the app, you can see that each of the child is now having a space of 20 points to the left and right hand side of it. And in the same way, there is another property that is called run spacing. And by using this property, we can add spacing to the top and bottom of each of the child widget. And if I add a space of 40 to it and save the app, you can see that each of the child widget is now having a space in top and the bottom also. So I can simply prove that by increasing the number of children, that is by copying and pasting the widgets. And if I save the app, so the container is now being overflown, but you can see that each of the child widget is now having a spacing of 20 for the left and right hand side and a spacing of 40 for the top and bottom. So other than the spacing, the last property that can be useful in a wrap widget is the text direction property. And by using this, we can change the way in which the widgets are ordered in the wrap. So let's come back to the simple example of 3 buttons, and I'll remove all the other buttons. And now we have a basic layout in which we have a button 1 on the start, button 2 on the middle, and button 3 on the end. And if I simply add a text direction property, And if I change the value of text direction to text direction.rtl, all the buttons in the view change their direction, and now the button 3 comes first, 2 comes on the middle, and 1 comes last. So basically, the text direction property changed the direction of the views on the x-axis, that is the main axis in this case. So all these properties are relatively simple, and they're more or less similar to what we have learned in the row and column widget. But their names are quite different in case of the wrap, because in wrap, you can change the direction of views according to your own need, and you can make the wrap widget a row by setting the axis to horizontal, and change it to a column by setting the direction to an axis of vertical. Unlike row and column, which are used to align their children vertically and horizontally, stack is used to place widgets on top of each other, that is along the z-axis. So like row and column, here we also have a children property, and with which we can give multiple children to the stack. So right now we have two containers, one with a red color and a 200 width and height, and another with a width and height of 100 and a color blue, arranged in a column with main axis alignment of center. So what I will do is I will just remove the main axis alignment and change the column to stack. So as soon as I save the app, you can see that the stack positions the widgets on top of each other. And the second child, that is the container with 100 of width and 100 of height and a color blue, is placed above the child that is having a 200 of width and height and a color of red. So basically, higher the position of child in the list of children, the closer it will be to the user. So the stack behaves a bit oddly in terms of width and height. By default, the width and height of the stack is decided according to the requirements of its children. So in this case, the maximum space taken by the stack is of 200 by 200, because this is the maximum width and height that is given to any of its child. But this behavior changes if we wrap the stack with another widget that is having its own width and height. So let's say I wrap the stack with a container, and I give the container a width of 400, a height of 700, and a color of gray. And as soon as I save the app, you can see that the contents of the stack moves to the top left corner of the container, and this is because the stack has now taken the width and height of the sized container. So basically, the width and height of stack depends on two cases. If the stack is wrapped with a widget which is not given a width and height explicitly, like the center earlier, then the stack will take the maximum width and height that is required by its children. And in the case in which the stack is wrapped by a widget that is given an explicit width and height, then the stack will take the width and height of the widget it's wrapped with, which in this case is the container, which is given a width of 400 and a height of 700. So in this case, all the children are aligned to the top left corner of the stack. So to change the alignment of children, I can simply use the alignment property of stack, and if I change its value to alignment.topRight and save the app, you can see that all the children are now aligned to the top right corner of the stack. And if I change it to bottom center and save the app, all the children move to the bottom center of the stack. So there are two other properties of stack which we have to look into, but before that we have to take a look at another widget, which is most often used with stack to position widgets in a much more custom way, and this widget is called the positioned widget. So to use it, we simply need to wrap the child with a position widget. And in this case, what I will do is I will change the alignment to top right, and I save the app. And what I basically need to do is I need to move this container, that is this blue container, to the bottom right corner. And for that, what I can simply do is I can wrap the container with the positioned widget, and I'll simply give some properties to this positioned widget. And in this case, I want the view to be at the bottom. I'll give the bottom a value of 0, and I'll give the same value to the right. So the reason for giving the value of 0 to the bottom and 0 to the right is that I want the view to have 0 distance from the bottom and 0 distance from the right. So other than the bottom and right, there are 4 more properties. So this top, height, and bottom deal with the vertical axis, and this left, width, and right deal with the horizontal axis. And out of these 3 vertical properties, that is the top, height, and bottom, you can only give value to 2 at a time. And in the same way, out of these 3 properties that deal with the horizontal axis, you can only give a value to 2 at a time. And in this case, I wanted to position the widget in the bottom right corner, so what I simply did, I gave the bottom value a 0, and I gave the right a value of 0. And so the widget, that is this container with a width and height of 100, is positioned to the bottom right corner of the stack. And the width and height property of positioned widget overrides the width and height that is given to its children. So in this case, if I give the positioned a width of 200 and I save the app, you can see that the container is now taking the width of 200 instead of its actual width of 100. So basically, if I also give a height to the positioned widget and change it to 300, let's say, and save the app, the container's height will now be overridden by the height that is given to the positioned. So positioned is really a simple widget, and it helps in positioning elements in stack. So let's come back to the stack now, and let's take a look at another property that is called fit. And the fit can be given 3 types of values, one of which is stackFit.lose. So basically what stackFit.lose does, it lets all the children of stack have their own width and height, restricting their values to the maximum width and height of the stack, which in this case is 400 by 700. So any of the child of this stack cannot have a width that is more than 400 and a height cannot be more than 700. So other than this stackFit.lose, fits can also be changed to stackFit.expand. And if I save the app, you can see that the stack is now filled with this container that is red in color. And this stackFit.expand forces each of the non-positioned children of stack to take the maximum width and height that is allowed by the stack, which in this case is 400 by 700. You must keep in mind that this only happens with the non-positioned widgets. So in this case, I do have this container which is 100 by 100 in width and height, and it is positioned to bottom right corner. And the stackFit.expand does not have an effect on this positioned widget. And in the case, if I remove the positioned and if I save the app again, you can see that the container that is 100 by 100 in width and height is now affected by this stackFit.expand. So let's say I change the bottom position of this container to -20, and if I save the app, you can see that as the container moves down, the remaining portion of the container is now clipped. That means any part of container that exceeds the bounds of the stack is now clipped from the stack. So we can change this behavior using the overflow property. So if I give the overflow a value of visible, and if I save the app, you can now see that the blue container, which is positioned at a bottom of -20, exceeds the bounds of the stack but is still visible outside the bounds of the stack. So using the overflow property, we can decide what we want to do with the widgets that overflow the bounds given to them by the stack. So if I change the overflow to clip and save the app, the remaining portion of the container is now clipped again. So by default, the overflow property of the stack is set to overflow.clip. So these are all the important properties of stack and positioned which might come in handy in Flutter UI design. What I have here is a center widget which is having a child of container, and the container is having a red color and a text that says welcome. It is not much of an elegant look when you see that the text here is touching the borders of the container. So in such cases, when you need to add some space between the boundaries of the parent and its children, you need to use the padding widget. To use the padding widget, what you need to do is you need to wrap the child with a padding. And the value of this padding property needs to be an edge insets. And you can create the instance of edge insets in multiple ways. Let's discuss the most useful ones. The most basic way is by using the edge insets.all. And by using this constructor, you can give a padding value that is similar for all the sides of the container. So in this case, I'll just give it a value of 15. And if I save the app, you can now see that the container is having a padding of 15 from its childs from all the 4 sides, that is top, right, bottom, and left. This is the most common way of giving padding, but you can also give padding in more selective ways. So if you need to give different padding for horizontal values, that is left and right, and different padding for vertical values, that is top and bottom, you can use edgeinsets.symmetric. So let us say we need a padding from only the left and right hand side. So in that case, we can give only the horizontal value to the edgeinsets.symmetric. And in this case, I'll just pass the value of 10 and put a comma here and save the app. And you can see that there is only a padding of 10 from the left and right hand side. So let me just increase the value of padding here so it's much more visible and save the app. You can now see that the padding of 20 is being applied from the left and right hand side only. And if I want to apply the padding from top and bottom also, so I can simply add a vertical property to the edgeInsets.symmetric and give it a value of 50 and save the app. You can now see that we have a different value for the horizontal padding that is from left and right hand side, and a different value for the vertical padding that is from top and bottom. And if you need even more control over individual sides, then you can simply use edgeInsets.only. So by using this constructor, what you can do is you can pass a different value for right, left, bottom, and top. So in this case, if I only give a padding value to the right and give it a value of 20 and save the app, you can see that there is only a padding of 20 from the right hand side. And if I want to add a padding to top also, so I'll just give it a property of top and give it a padding of 50 and save the app. And there is a padding from top also that is of value 50. Other than these, there is another way of giving edge insets. It is a bit advanced because this is mostly used in case of animation. We can use edgeinsets.lerp. So let me just remove this from here and pass it edgeinsets.lerp. And the lerp here stands for linear interpolation. To use this, what we need to do is we can give two values for the edge insets. You can consider them as limits. For the first argument, I'll pass in the edgeinsets.all and give it a value of 10. And for the b, I'll pass in the edge insets and give it a value of 20. And the last argument that the lerp requires is like a control handle. And what you need to do is you need to pass a double value here, which can be between 0.0 and 1.0. What you can do is you can pass in a value of 0.0, and if I add a comma here and save the app, you can see that we're applying the padding of 10. And if I pass in the value of 1.0 and save the app, the padding that is being applied now is the padding of 20. So basically, if I pass in the value of 0.0, the first padding will be considered, and if I pass in the value of 1.0, then the second padding will be considered. And if I pass in the value of 0.5, the padding of 15 will be applied. And 0.5 represents the value that is 15 between the 10 and 20. This kind of interpolation is mostly used with animation, where you can interpolate between two padding values. So I hope you have a much better understanding of padding widget, and you can apply padding in other ways also, rather than just using the common constructor of edgeinsets.all. Creating UI for mobile applications has a number of challenges. You need to plan and implement your app's behavior on different devices with different screens and user settings. You need to check the device size and orientation, font size, and other properties to display a responsive UI that fits the device screen comfortably and doesn't affect the user experience. To get such information about the device and user settings, Flutter SDK provides us with MediaQuery. To use the MediaQuery, what you need to do is you need to use the MediaQuery class and use the auth function, that is a static function, and give it build context. To provide the build context, you need to be in this build function, and then we can access the information directly from the MediaQuery. There is a lot of information that is provided to us by the MediaQuery, and all of this cannot be discussed in a single video. So we'll only be taking a look at most important properties of MediaQuery that you're likely to use during your Flutter app development, such as size and orientation. Starting with the most used one, that is size. Using this, we can get the maximum size of the screen available, and we can get the width and height. So what we can simply do is we can use the size property, and this gives us an instance of size. So what we will do is we'll create a new instance of size and just name this size and put it equal to the MediaQuery instance of size. So let's say we have to place two containers in a row where each container is taking half the device width, and both the containers in total fill up the device width. So in that case, what we can do is we can replace this text with a row, and we have to give it children property, and in this children we create two containers in which each of the container is having the width and height that is equal to half of the device width. What we can do is we can create a simple container, and in this container we can give the width that will be equal to size.width, that is divided by 2. And we can do the same thing for the height, and we'll just change this to height. And just for some distinction, I'll just give this container a color, and what I will do is I'll just copy this container and create a duplicate and change its color to green. And when I save the app, you can see that in the device we have two containers with equal width and height that in total cover up the whole screen width. So this is all possible by using the MediaQuery and its size property. Other than the width and height, size also gives us with other useful size information such as shortest side and longest side. So just to demonstrate, let me just remove this row from here, and let's say we have to give this container a size that fits in the device dimensions comfortably. So for that, what we can do is we can simply use the width and height property of the container and give it a size that will be of shortest side. So in this case, the shortest side will be the width, and hence we will not create a container that goes beyond the width and height of the screen. So if I give the height also and keep it to size.shortest side and give it a color of colors.red, you can see that the container now takes the width and height that is equal to the shortest side of the screen dimensions. So using the shortest side here guarantees us that the width or height of the container won't exceed the dimensions that are given to us by the device width and height. I cannot explain to you each and every use case in which the size information will be useful, but majority of the use case of size is with the width, height, shortest side and longest side. Other than the size, MediaQuery also provides us with orientation. So the orientation gives us with an instance of orientation, and we can get that in the same way as we did with the size. So for that, I'll create an instance of orientation, and I'll just name this orientation and put it equal to the MediaQuery instance. To demonstrate the use of orientation, let me use a simple example. In this example, I'm using the orientation data given to us by the MediaQuery and using it to create a responsive UI. So in this case, I have the information displayed in a column which has two containers aligned vertically. So if I rotate the device to a landscape view, and now the information is being displayed horizontally in a row. So I'll just change the orientation again. So in this case, what I'm doing is I'm getting the size property from the MediaQuery, I'm getting the orientation from the MediaQuery, and decreasing some width from the shortest side to give it some padding, and using that for each of the side of the containers that you see here. So in the scaffolds, I have a center in which I'm using a builder so that I can check whether the orientation is landscape by using the index property of the orientation. You can compare the index of this orientation with a constant that is orientation.landscape.index. And if the values are same, we display the information in a form of a row, or else we use a column. So in this case, you can see that I have a function here that says layout children, which takes in the boxed side. That is the size of each of the side of the containers. So basically, this layout children is a function that I've created so that I don't have to repeat the code for each of the row and column. So just by using the MediaQuery, we can create a simple and responsive UI. There are other widgets in Flutter also, like Layout Builder, which help you decrease this complexity. But there are some cases in which you have to use the MediaQuery directly to get some fine-grained control over what you can do with your Flutter UI. Other than this most used properties of size and orientation, MediaQuery provides you with a number of other options. For example, if you're creating an application that deals with time in some way, you can use the always use 24-hour format and use this in your application to display the time to the user in the format that they request. Other than this, you can also see the property of disable animations, and if your application is using animations extensively and the user has explicitly disabled animations, so you can get that behavior from the MediaQuery and then reduce your animations in the application. There are other features like view padding and view insets, so you can keep the track of device and system specific boundaries such as notches, status bar, rounded corners, etc. But rather than directly using these properties from MediaQuery, that is of view padding and view insets, there is a quick and easy widget just to do that. And sometimes when you have to keep your UI safe from device and UI specific things such as notches, status bar, rounded corners, etc., you can use SafeArea. Let's go back to the basic example that we had before. So in this, let me just remove the width and height from here and save the app, and also remove the size from the MediaQuery. Right now, you can see that the container is taking up the area of status bar also. But in normal applications, you have to leave this area out of your application screen. And for achieving just that, we can use the SafeArea. So in this case, I'll cover the scaffolds with the SafeArea and save the app. And instantly, you can see that now the UI is below the status bar. SafeArea does the same thing that it did with the status bar for the notches and punch hole displays also. You can test this on a real device because on the emulator, the device screen is just for decoration and it does not really give the real information to the system UI. SafeArea also gives us 4 properties for the top, bottom, right, and left, and we can remove the padding given by SafeArea for a specific side by turning these properties to false. So right now, we're protecting our application UI from the status bar, but if I turn the top property to false and save the app, you can now see that the SafeArea is not taking effect from the top side, and the container is again taking the space of the status bar. SafeArea is basically a really focused version of MediaQuery, and we can get the same functionality by simply wrapping the scaffolds with a padding. So let me just demonstrate that. So if I remove the SafeArea and save the app, and now cover the scaffolds with a padding, and I'll just remove this default value, and what I will do here is I'll get the MediaQuery by MediaQuery.offContext, and I'll get the view padding, and this gives us the information regarding the edge insets to keep the device and system UI out of the way. So in this case, I'll store this information into edge insets, and now I can use this edge insets for the padding property of padding widget. And if I save the app right now, you can see that we get the same behavior that we did with the SafeArea. While creating UI for mobile applications, you have to keep all these things in mind, and MediaQuery and SafeArea are one of the most important widgets that you have to use in order to get device-specific information. Every application that you create has to have a text in it. Flutter SDK gives you with more than enough options to create any type of text for your application. Like any other thing, text is also a widget given to you by Flutter SDK. To create text, you need to simply use the text widget, and you need to pass a string of the text as the first argument to this text widget. This gives you with the simplest form of text for your application, which looks something like this. But Flutter is all about UI, and you might need to format this text in different ways to make it more appealing. For this, text has a property called style, and this style takes an instance of text style. Text style is quite a detailed class on its own. The most basic properties in text style includes font size, which requires a double value. In this case, I'll just pass a value of 20.0. And you can just pass 20 also. Then comes the color. So I'll just pass the value of color to colors.blue. And as soon as I save the app, you can see that the default looking text changed its size to 20 and the color to blue. Other than the font size and color, there is font weight, with the help of which you can make the text bold according to your need. The value of this font weight can range from 100 to 900, but you can only use the range that is supported by the font that you're using. Other than this range, there are other type of values like bold and normal, so in this case I'll just be using the bold. And as soon as I save the app, the text becomes bold. We can also apply a background color, and I'll just keep this colors.black. And for now, I'll just change the color to color.white and save the app. So you can see that the background color of the text changed to black, and the background color will only cover the space that is covered by the text. So in this case, I'll just remove the background color property, and I'll change the color back to blue. Other than the background color, you might also need to decorate the text with underline, overline, or a line that goes through the text. This can be done using the decoration property, which can either be overline, underline, or line through. So if I just set it to underline, you can see that we have a nice underline with the text. I'll increase the font size so that the underline is much more visible. I'll change the text size to 40 and save that, and you can see that we have a nice clean underline with the text. You can also combine multiple values for the decoration. And in this case, we can use text decoration.combine. And in here, we can pass the list of text decorations. So I'll pass the first item as text decoration.underline and the second item as text decoration.overline. And if I save the app, you can see that I have the text with a line above and a line below. We can also change the thickness of this decoration by using the simple property of decoration thickness. So I'll keep this to 2.0 and save the app, and you can see that the lines become bold. But the color of the lines is still blue. So to change the color of decoration, you can use decoration color and set the value of color to colors.red or something else. And if I save the app, the color of the decoration lines become red. And you might also not want your decoration lines to be a straight solid line. In such cases, you can use the property called decoration style and set the decoration style to text decoration style for wavy or dashed. In this case, I'll just use dashed and save the app, and you can see that the decoration lines become dashed. I can also set them to wavy, and as soon as I save the app, you can see that the lines take the shape of a wave rather than just a straight solid line. Other than the decoration properties, you might want the words and the letters in your text to have custom spacing between them, and this can be achieved by using letter spacing and word spacing. And if I change the value of letter spacing to 2.0 and the value of word spacing to 4.0, you can see that the space between the letters is increased and the space between the words is also increased. And if I change the value of word spacing to a bit more and make it 20 and save the app, you can see that the space between the words, that is hello and world, is increased. And if I change the value of letter spacing to 1 and save the app, the letters come close to each other. And if I increase this to 5 and save the app, the space between individual letters is increased. So word spacing and letter spacing are nice tools to have to make a clean looking text in your application. Text in Flutter also supports a shadow property, and this takes a list of shadows. So just for demonstration, I'm going to pass a single instance of shadow, and in this I'll pass the color to be colors.black, and the blur radius to be 2.0, and the offset to be offset of 1 by 1. You can see that the text now has a nice shadow for it. And if the shadow is not quite visible, what I can do is I can increase the X offset and make it 4 and save the app. You can see that the shadow is not visible. So with just a few lines of code, we're able to add a nice shadow to our text, which can otherwise be a difficult task. So the next property we're going to discuss is font family. By using the font family, we can change the fonts for a text widget. For adding the font family, I'll remove all the unnecessary properties that I've added to the application till now. I have the fonts here in the TTF format, and what I will do is I'll take 2 files from here and copy them and come back to the application and create a new folder here. And I'll name the folder assets, and in this folder I'll create a new folder that is called fonts, and in this folder I'll paste the fonts that I just copied. So I have a railway-bold and a railway-regular, and both the files are of TTF format. The next thing that I need to do is I need to come down to this pubspec.yaml file, and in here I need to come down to fonts property. And what I will do is I'll just uncomment this fonts, and I need to adjust this according to my own needs. And once this is done, I need to adjust the indentation of all these properties. In the pubspec.yaml file, you need to also keep track of the indentation, because if the indentation is not correct, your app will not get built. So once this is done, you can click on package upgrade and the application will build. So what I need to do now is I need to pass a string to the font family, and this can be railway. And this name corresponds to the name that I've given to the family of pubspec.yaml file. So once the application runs, you can see that just by doing these few steps, we have changed the font in our application. And it looks much more elegant than the default font given by Android. So to make this more visible, I can also add the font weight property and set this to fontweight.bold. And if I save the app, you can see that the text becomes bold and with a new font that is railway. So other than the font, there is one other property of text style that you might find useful and interesting, and that is foreground. And what this foreground requires is a paint object. And with the help of paint, you can do a lot of things with this text. In this case, we'll just be adding a stroke to this text. For that, what I can do is I can use this paint object here and add a color to it. And I can change the stroke width and set it to 2.0. And along with this, I can also change the style of this paint. And I'll change the style to paint style.stroke. And also, to use this foreground, we need to remove this color property from here, because now everything will be painted by this foreground using this paint. And if I save the app, you can see that the color is removed and we have a nice stroke for the text. And if you're not familiar with what this line is doing, it's basically something like this. This is the old conventional way of doing stuff, in which we create a new object and then change the properties of that object. But instead, in new dot, what we can do is we can create the object and continue the line until we have changed all the properties and then add the semicolon. This basically reduces the boilerplate that we have to write in the old way of creating objects. So this covers the text style section of the video, and you can see that Flutter SDK provides us with a bunch of options to decorate our text in Flutter. But decoration is not enough when we're dealing with a large number of text. We have to keep in mind the alignment of text and the other ways in which text should behave when there is a lack of space. So let's increase the content of the text and change the font size. And I'll keep this to 15. And I'll also remove the font weight and the foreground property from here. And instead, I'll add the color that is colors.black. And if I save the app, you can see that the text now wraps down to multiple lines if there is not enough space to display the text in a single line. And in such cases, you can see that the text is not properly aligned. For that, we have to use the text align property, which is not a part of the text style. So we have to move outside of it. And outside the text style, I can add the text align property, and this can be set to text align.center, right, left, or justify. So I'll set this to justify, and if I save the app, you can see that the text is now justified to the left and right hand side. And if I change the align to right and save the app, you can see that the text is now aligned to the right hand side. Other than this, we can also change the direction in which our text is being displayed. So for that, I'll just change the alignment back to justify, and I will add the text direction property. And in this, I can pass text direction.rtl, and now you can see that the text is being written from right to left instead of the default direction of left to right. So in this case, I'll just remove the text direction and save the app. So let's say we are in a situation in which we know that there are going to be multiple lines of text, but we can only afford to display 2 lines. In that case, what we can do is we can change the maximum lines property and set this to 2. And if I save the app, you can see that the text is now being displayed in 2 lines only. But this raises another problem, because here the text is being clipped abruptly. And there is no way for the user to know whether there is more text to read or this is the end of the line. So in such cases, what we can do is we can use the overflow property. And in this, we can set the value to text overflow ellipsis. And if I save the app, you can see that there are 3 dots in the end of the text, which tells the user that there is more text to read. And if you want to keep the text to cover only a single line, what you can do is you can set the max lines to 1 and save the app, and the text will only cover a single line. But there is another way to do this. For that, what we can do is we can set the soft wrap to false. And now the text won't wrap, and we will be presented with only a single line. And in this case also, we will be presented with 3 dots to show that there is more text to read. Other than these important properties, there's also properties like text scale factor, with the help of which you can scale the text, and this can be used to show a magnified version of the text that is in the application. So in this video, you can see that there are a number of alterations that we can do with our text in Flutter applications. And this makes text as one of the most highly featured widgets in Flutter. Okay, so let's start this video with a question. What would you do if you have to create something like this in your Flutter apps, in which you have to have multiple text widgets with different styling, or you have to add an icon along with the text, or something like this in which the user can click on certain text and he's taken to a separate URL or something? Well, the most common approach when beginning with Flutter would be to create a row and then add all these widgets as children and so on. Although it's perfectly good and you won't need to think of any other way, but structuring everything in a row can be a bit tedious, especially if widgets grow in count. For example, if there are more than 2 text widgets here, or you have to have some other text along with the icon on the right hand side, then there can be some issues of overflow. And if you have to add something like this, you have to manage different gesture detectors to detect the user's click on portions of this text. And you can see how this can turn into a widget tree hell. Well, as you all know, that Flutter takes UI pretty seriously, and it gives us with an awesome widget called RichText. So let's take an in-depth look at RichText and how you can use it in your own Flutter apps. In this tutorial, we'll be taking a look at something like this, which you might have seen on the login screen of certain apps. At this point, I have used row to create this, but instead we'll be using a RichText. So I'll replace this row with a RichText, And this rich text requires a property of text which takes an object of inline span. There are multiple types of inline spans that you can use depending upon the content, but in this case, I'll just be using a text span. And in this text span, there are certain properties that we can use. In the text property, we can pass the simple text that we want to add. And there's also a style property with the help of which we can style our text. So first, I'll just add a simple text, and I'll add the text of don't have an account. And at this point, if I save the app, you can see that nothing appears on the screen. And the reason for this is because we have not passed any style to this text. And by default, the text is coming out to be white. So in this case, I'll just pass in a style and give it a property of text style, like we give to a normal text widget. And in this, I'll pass in the color property and put it colors.black. I'll save the app, and you can see that we can see the text of don't have an account. I'll also increase the size of this text by passing in font size, and I'll just pass in a size of 20. Now, to add the register text, what we need to do is we need to use another property of this text span. So I'll come below the style, and here I'll add the property of children. And here you can see that it requires a list of inline spans. So here you can imagine that we can split our text in multiple forms, and we can apply different styling to each of them. So in this case, I'll just add the children property, and here I'll pass in a list, and in this list I'll also add a text span. And in this text span, I'll pass in the text of register, and if I save the app, you can see that the register is right here. At this point, by default, this register is taking the style that is applied to its parent, that is this text span right here. So we need to change the color of register here, and we want to make it bold. So what I'll do is I'll add a style property and pass in a text style, and give it a color of colors.red, and give it a font weight of fontweight.bold. And if I save the app, you can see that the color of register is now red, and it's bold in comparison to the text on the left hand side. What we also need is we need to add a bit of space between them. So what I'll do is I'll come up to the text span here, and after the account and the question mark, I'll add a space and save the app. And you can see that the changes reflect on the app, and we now have a space between the register and the don't have an account text. At this point, the UI is done, but there's no way of detecting the user's click on this register text. And without that, this text has no use. Well, the text span has another property for solving this problem too. So for detecting gestures, what we can do is we can come here in the text span after the text style, and we can add another property that is called recognizer. And this takes an instance of gesture recognizer. And for creating a gesture recognizer, what I'll do is I'll come up here and create a final variable of type tab gesture recognizer. And you can see that there are other type of gesture recognizers too, but I'll leave it up to you to try them according to your own needs. What I'll do is I'll create an instance of tab gesture recognizer and name it gesture recognizer. I'll just minimize the emulator, and here I'll initialize this with a constructor of tab gesture recognizer. And what I need to do is I need to give a value to the onTap property of this. So for this, I'll provide it a function, and here I'll just pass in debug print and give it some text of hello world. So once the gesture recognizer is ready, we'll pass the same gesture recognizer for the recognizer property of text span, and I'll open up the run window, and I'll just run the app. Now once the app runs on the emulator, you can see that we have the text here, and if I click on register, the hello world text appears on the run window. So our gesture recognizer is working correctly. There are endless possibilities of creating complex text-based applications in Flutter using the RichText Widget. But the RichText Widget does not limit itself to only the text span. But instead, we can also use a widget span. And here you can pass in any type of widget as a child of this widget span. So in this case, I'll just pass in an icon. And also, I'll change the text of this first text span to share. And here you can see that we have a share string with an icon alongside. At this point, if I just change the size of this font to 30 or 40 instead, you can see that the icon is not properly aligned with the text. And for that, we can use the alignment property of the widget span. And in this alignment, we need to pass in a value in the form of placeholder alignment. And for now, I'll just use placeholder alignment.middle. And now you can see that the icon is now vertically aligned according to the height of the text. You have seen that the possibilities with the rich text are endless. So if you find this video useful, please hit the like and subscribe button, and consider supporting me on Patreon for more Flutter videos coming your way on Flutter Widget Essential series on Retro Portal Studio. See you next time. Peace.